I am on page 74 still at the bottom at example number 7. And we're looking this time at dependent probability. And I went ahead and I drew the cards in that illustration just to help us picture a little bit better. And here's the story. Suppose you randomly take 2 cards from these 4 cards. What is the probability that both cards will be face cards? So the probability of a face card and a face card. We're going to choose 2, and we want both of them to be face cards. And a face card is one of the cards with the people on them, like a king, a queen, or a jack. So we have 2 face cards in this series. We have the King of Diamonds and the Queen of Diamonds. The others are 5 of Hearts and then 8 of Diamonds. So the 5 of Hearts and 8 of Diamonds are not favorable outcomes here. So the probability, let's do the first one. The probability of a face card on the first draw is, out of 4 cards, there are 2 face cards. So let's say that on the first draw, I draw the Queen of Diamonds. So we're going to take her out. We're not going to put her back in. Then on the second draw, we want to get another face card. Well, the only one left is the King of Diamonds. That's out of 3 cards. There's 1 face card. That would be the King of Diamonds. And then once we take him out, he's out of the mix. So what's the probability that what I just described would happen? Well, we have an and here. We have the probability of 2/4 and 1/3. That is a multiplication problem. So we end up with 2 over 12, which is 1 over 6, which is approximately 1 divided by 6 is 0.17 or 17%. This is called dependent probability because once you take out the Queen of Diamonds, the numbers for the next probability change. And you have to always make sure that you're understanding how they change. These are said to be without replacement because once a card is chosen, it cannot be chosen again. And that's very important if you're doing a problem.